Good morning, students. This is Sanchita ma'am. Let begins the new topic and the last topic, that is the electric bell from the chapter 14, electric current and its effect. So, what is an electric bell? An electric bell works on the magnetic effect of current. It has an electromagnet in it. So, first let us explain let me explain the construction of electric bell. The electric bell has a U-shaped electromagnet. I think you have seen the electromagnet is there having the insulated copper wire on around it. Yes, so this is the electromagnet and a small iron bar which is known as armature. So this is the armature, the small iron bar. So this is the armature. It is held in front of the poles of the electromagnet. So these are the two poles of the electromagnet, north pole and the south pole, and in front of this pole a small iron bar is there which is known as armature. The lower end of the armature is attached to a flat spring. So can you tell me where is the flat spring is there? So this is the flat spring. So this is attached, that means lower end of the armature, it gets attached to a flat spring and the spring itself is fixed to a metal bracket. The upper end of the armature has a hammer. So this is the hammer. Upper end of the armature has a hammer attached to it, and there is a contact screw which just touches the armature at the point E. So this is the point E. Here we can see a screw which touches the armature at point E. A metal gong is fixed near the hammer. The electromagnet is connected to a battery, a push button switch, and the armature in a circuit. So this is a complete circuit with the help of the connecting wires. The connecting wires are there. So it forms a complete circuit. Now the working of the electric bell. When we press the switch, the electric circuit of the bell is completed. When we press the switch, that means that time the switch is in on position. It is closed. The switch is closed and the electric circuit of the bell is completed. We can say it is a complete circuit and the closed circuit, and current passes through the coil of the electromagnet and it gets magnetized. That means the electromagnet, when the electricity passes through the coil of the electromagnet, then the electromagnet, it gets magnetized and the electromagnet attracts the armature. It attracts the armature towards itself, and the hammer attached to the armature, the upper end of the armature, it strikes the gong and produces a sound. Again, I am explaining you. When we close the switch, we press the switch gets closed and there the circuit becomes completed. Then what happens? Through the connecting wire, electricity reaches the coil of the electromagnet and the electromagnet gets magnetized. Then it attracts the armature which is in front of the poles of the electromagnet, And what happens then, when it attracts the armature towards itself, the hammer also moves towards the electromagnet, and automatically strikes the gong and produces a sound. Now, when the armature moves towards the magnet, its contact with the contact screw, because the contact screw gets attached to the armature at the point E. Now, when the armature moves towards the electromagnet, that time the contact screw is broken. The attachment between the armature and the contact screw at the point E gets broken, and due to this the electric circuit breaks. No current flows through the electromagnet coil. Electromagnet loses its magnetism, and the armature is no longer attracted by the electromagnet, and the spring brings back the armature to its original position, and the hammer moves away from the gong, and there is no sound. Then, as soon as the armature comes back and touches the contact screw, the circuit again gets completed, and the current starts flowing in the electromagnet coil again. This process of make and break of the electric circuit occurs when we press the switch. Thus, the hammer strikes the gong, rapidly producing almost continuous sounds, and we say that the bell is ringing. So, this is all about the working of electric bell.